Hi students, in the previous session you learned about mechanism of ascent of sap. In that you learned the process of transpiration of water and solute from the reason of absorption, which is down in the root system, to the reason of utilization and transpiration, which is the set of leaves at the top, is indeed a fascinating activity in the plant body, mainly because it occurs so efficiently against the direction of gravity, even to such great heights like those of the giant redwood tree, which grows up to 100 meters or more. Several theories have been proposed in an attempt to understand the mechanism of ascent of sap. Several vital theories based on the participation of the living tissue, such as cell pulsation theory, root pressure theory, and several physical theories based on the physical force, such as imbibition, capillary, free, transpiration, pull, etc., have been proposed from time to time to explain ascent of sap. But none of those, except transpiration pull theory, enjoyed much support. The most important and widely accepted theory is transpiration pull theory. Two Irish botanists, Dixon and Joly, proposed this most popular theory in 1985 on ascent of sap. This theory is also known as cohesion-tension theory. This theory explains the mechanism on the basis of certain simple and fundamental phenomenon in the plant body. It has been supported by Renner, Curtis Clark. This theory based on the following features. Plants passively transport water through the xylem. Cohesion is the tendency of water molecules to bond with each other. Adhesion is the tendency of water molecules to bond with other substances. Cohesive pores, nothing but intermolecular attractive pores, is so strong in water that water molecules tend to remain in a continuous unbroken column inside the plant. It is said that the cohesion force in water is so strong that even a tension ranging from 30 to 300 bars, the column of water may not break in the plant body. Adhesive pores, it is nothing but molecules of water also exhibits a very strong adhesive pores, that is a pores with which they cling to the other surface like the cell walls of xylem elements, cell walls of mesophyll cells, etc. Thus, water in the living plant body is visualized as one continuous and elaborate body or column held by the cohesive and adhesive forces of water molecules. I think you understood these 2 points. Cohesive is nothing but the attraction force present between two water molecules. You may also call intermolecular attractive force. And adhesive means the same water molecule can bound with cellular surfaces. These cohesion and adhesion create a tension within the xylem that helps move water upward. In this picture, you can easily understand about addition cohesion of water molecules. Especially in plants, cohesion means pores that holds water molecules together. Adhesion means water molecules stick to certain surfaces. You can see so many examples in nature also because of cohesion and attraction of water molecules with other water molecules to form oceans, rivers, and the water in your glass. Cohesion also creates surface tension, the skin on top of water that allows things to float on it. If you think, okay, what causes cohesion and adhesion? Hydrogen bonding allows for cohesion, the attraction between molecules of the same type. Water really likes to be close to other water molecules, even going as far as beading upon smooth surfaces. Dew droplets are excellent examples of this. Cohesion is also why some insects can walk on water. Similar to cohesion, adhesion is the attraction between the molecules of different substances. Water uses adhesion when its attraction to another substance is greater than the water's attraction to itself. If you have ever dropped a cup of water on a hardwood floor, you know that it spreads out instead of forming beads. This is adhesion. Adhesion and cohesion are important to water properties that affects how water works everywhere, from plant leaves to your own body. Just remember, cohesion means water is attracted to water, and adhesion, water is attracted to other substances. Water is sticky and clumps together into drops because of its cohesive properties. More precisely, the positive and negative charges of the hydrogen and oxygen atoms that make up water molecules makes them attracted to each other. Some more details regarding cohesion and adhesion in liquids. The soap bubbles that the child blows into the air maintain their shape because of the attractive force between the molecules of the soap bubble. The soap bubbles in this photograph are caused by cohesive forces among molecules in liquids. Children blow soap bubbles and play in the spray of a sprinkler on a hot summer day. An underwater spider keeps his air supply in a shiny bubble it carries wrapped around him. A technician draws blood into a small diameter tube just by touching it to a drop on a pricked finger. A premature infant struggles to inflate her lungs. What is the common thread? All these activities are dominated by the attractive forces between atoms and molecules in liquids, both within a liquid and between the liquid and its surroundings. Attractive forces between molecules of the same type are called cohesive forces. Liquids can, for example, be held in open containers because cohesive forces hold the molecules together. Attractive forces between molecules of different types are called adhesive forces. Such forces cause liquids or liquid drops to cling to window panes. For example, in this section we will examine effects directly attributable to cohesive and adhesive forces in liquids. Finally, you may understand cohesion and adhesion of water molecules by using this picture. Water has the capacity to form intermolecular associations with molecules that share common properties. Because water is a polar, it will be attracted to other molecules that are polar or have an ionic charge. Thank you.